So this lesson is going to be about how we rearrange equations, which is really, really important at GCSE and at A level. So the idea that we're going to be looking at is isolating terms or terms. And we do this to allow us to rearrange an equation into a different form. So each one of these equations is about trying to find x on its own. It's about trying to isolate x. And each one will require a slightly different skill. So this first one, you'll see that this is our term that's containing x. There's only one term containing x, which makes it a little bit easier. And so we're going to isolate this term, which means every other term essentially needs to be on the other side of the equation. So that's going to give us ax squared equals c minus bq, because it's gone from a positive term to a negative term as we moved it across. The next thing I'm going to do now is going to isolate the x. So at the moment we've got a times x squared. So if I divide or escalate the a down, I get an expression looking a little bit like that. So I've got an expression for x squared now. And the final step then, well, the inverse of squaring is square rooting. So we have to put x equals big square root of the term. And because it's a square root and we don't know the actual scenario or the situation, we could get a positive or a negative answer, because we know a negative squared gives us a positive answer. If it's a measurement of length, then obviously we only give it as a positive value, but because this is an algebraic function, we need to give it as both positive and negative solutions. So there's two solutions there. Right, for this next one then, you'll notice how the ax, the bit we want, is already connected. It's already inside a bigger term, because this term is all connected because it's all divided by. So what we're going to have to do here is we're going to have to escalate to get rid of the divide by the whole thing by nv. So we're going to have rp plus ax equals, and again, it doesn't matter what order we put them in. We could write that as f times n times v, or n times v times f, because when you're timing things together, it doesn't matter what order you do them in. The next thing then we're going to do is we're going to isolate the ax term. So that's the term we're after, which contains the x. So again, we've got to get rid of rp, which means we're going to subtract rp from the other side of our equation. And then finally, to get rid of a multiplied by x to leave us just with x, we escalate down. So we're dividing the whole thing by a. And that is our solution for x in terms of the other variables. This one's a little bit more difficult now because there's lots of problems. We've got a fraction, the same sort of problem we had with this one. And we've got the other problem, actually we've got two terms now which involve x, which means that when we've got a term appearing more than once, we have to do some factorising a bit later on. So the first thing we're going to do is we're going to get rid of the fraction. We're going to escalate that up. So n plus px equals v, all multiplied by rx at s. And what we're now going to do is we're going to expand the brackets to get two separate terms on the right hand side. So vrx add vs equals n plus px. And then what we're going to do is, because we've now got two terms that both include the letter that we want, we're going to gather them on one side of the equation. And again, look at the terms, try and keep as many terms positive as you can. So I think what I'm going to do here is I'm going to move the px to the right hand side. So we're going to have vrx minus px. So I've moved it across to make it negative, and that's going to be equal to n minus vs. And the next thing I'm going to do now is, looking at this side over here, I've got an x common to each of these terms. So I'm going to take out a common factor of x, which gives me vr minus p equals n minus vs. So by taking out a common factor, I've gone from two separate terms involving x to a single term involving x. And that's the key process really. Whenever you've got the term appearing more than once, you factorise it out to get it to a single term. And then we're going to escalate that VR minus P down. So we've got N minus VS over VR minus P. And that is our solution for X in terms of the other variables. Right, this one, I've put this one on now because there's lots of different ways to do this, and I thought I'd show you one where you can sometimes get in a bit of a muddle if you don't use certain techniques or methods. So the idea with this one was we had two terms and we took out a factor of X to get it to a single term. Now if we do that here, we'd have a bit of a problem, because if I take out a factor of X, what it would give me is 1 over n, because X times 1 over n is just times in the numerator. X times 1 is X divided by n, which would give us that first term. And the second one, we'd have P over m, and that would be equal to V. Now that's fine, and technically it's mathematically correct because we've taken out a common factor of X of each of these terms. It's this next bit that I don't like, mathematically speaking, because what we'd do next is we'd escalate down that 1 over m and P over m. Now in terms of actually mathematically speaking, that is a solution. It is X in terms of the other variables. The thing I don't like about it is the fact that it's a fraction inside a fraction. Now if I was substituting in values for V, N, P and M, I wouldn't mind, because I'd just be substituting them in and getting a value out. But because I actually want it as an equation, I prefer it to look like a simplified equation of sorts. So what I'm going to do is show you an alternative technique for this one. And that is the idea of using our fractions, because what we want to do is we want this to look something like this. We want it to be a single fraction so we can escalate that term up. Now in order to make that a single fraction, we're going to use our wigwams, okay? Because then we'll have a single fraction with a single denominator. So if you multiply across the bottom, we're going to have nm on the bottom. If we multiply top left, we get mx, and top right, we get npx. And again, the order isn't too important. And what we can do now is we've got two separate terms involving x, which we'll worry about in a minute. But let's get rid of this divide by nm. So we're going to escalate that across. So mx plus npx equals vnm. And then I'm going to take out a factor of x on the left hand side because it's got common factors. So m plus np, and that's vnm. And again, the order doesn't matter too much on the right hand side. And now you can see I've got my single term of x. I've got my two terms as the common factor multiplied by x, and so I'm going to escalate that common factor down. So vnm over m plus np. And what we've got there is we've got an answer which is just a single fraction. There's no fractions inside fractions. It's not ugly mathematics. It's a very pretty solution for x in terms of the other variables. Okay.